Welcome back. This video covers Python modules, a way to create code that is reusable across files and projects. Python modules are straightforward. They're Python files. When you create a Python file that's intended to be a module, that means it's intended to be imported. You do that with the Python import statement, which we've seen already, such as import numpy. But in this case, if you have a module name that's named module name.py, we would import it with import and then module name, leaving off the .py extension. When the import statement is run, all of the code in that file is run with an important distinction. The names and the function definitions are available in there as module name.name. So if you defined a name like A inside module name, it would be module name.a would be the name in the file in which you ran the import statement. However, the import statement has another way that it can be used that allows the user of the module to reduce this complexity. From module name, import, and then any names. Let's see how this works in practice. Over in VS Code, I'm going to create two files. One's going to be called physics.py, which is going to be the name of our module. And the other one is going to be a Jupyter Notebook, main.ipynb, that we're going to use to test our module. Over in physics.py, we're going to define some things that are relevant to physics. For example, gravity is 9.81 meters per second. It's a constant that we can use instead of writing 9.81 all the time. And we could also define some function definitions. So def, for example, projectile range, velocity, and given a velocity, we can return 2 times velocity of 0, implying that velocity is a list, times velocity of 1, implying it's a list containing 2 elements, divided by gravity. And if we looked up the definition for projectile range, we can see it's 2 times Vx times Vy over gravity. So we have some stuff that's relevant in here to physics. We might also want to, for example, write some tests. So, for example, we might write print projectile range of 10, 10. And we could run this file if we want to. And we'll see when we run this that the terminal will open. It'll run, and it's going to give us the projectile range. In this case, we needed to provide it a list. That's why we got an error. So I'm going to provide it a list and run it again. And we can see it prints out 20.387, which is 2 times 10 times 10 times 9.81, roughly. Okay, so that's a basic definition here. And we can go over to our notebook file now. And so we can see both of them. I'm going to open this, or at least split this downward and close this. So now we can see in VS Code that we can edit 2 files essentially simultaneously, but I wanted to keep this up and running. But over in main.ipynb, suppose we wanted to use the physics module. Maybe we wanted to use the projectile range function. We wanted to use the definition of gravity. And so what we can do now that we have physics.py defined is import it. Import physics. Notice I'll leave off the .py. And run that. Now what's interesting here is it printed out 20.38735, whatever, right? It printed out the projectile range because importing the file runs the file. Now what's typically done to avoid that, because normally when we import something nothing runs, is that we can wrap this in a special if statement, if underscore name double equals underscore main underscore, then print this. What that does is that this special variable is defined by Python, and if that special name is main, that means this is the file that's getting run. When something is imported, this will not be true, and we won't get that print statement. And so now when we import physics over here, nothing's going to happen because we wrap this in main, but when we run physics.py, we still get that 20.387. So we can import this module. By importing the module, we do get access to things like physics.gravity. We can also print physics.projectile range. Give it a list. Let's do 1010 again. Right? So you can see that you can use things that were defined in the module. It's essentially the equivalent if we had taken this code, dropped it into our Jupyter Notebook instead of import physics, and then used it. So importing something is very similar, or allows us to, very similar to writing it, but it allows us to reuse that code in other files, in this case, our Jupyter Notebook. Another way you can import is to import everything that's inside the module. So I can write, instead of import physics, I can write from physics import, and I can list the names like this if I wanted to and say specifically what I want, or I can import specifically everything, or not specify that and import everything with import star. Now, in order to illustrate this, I do have to restart the kernel. You wouldn't normally have to do this, but if you have a previous import statement lying around, that sort of takes precedence over this from statement, and so I need to restart the kernel to make this work. But I'm going to run this code from physics import star. Because I've done this, I now have gravity defined directly without needing to put physics.gravity, and same for projectile range. And so I did this from physics import star, and now I can directly use gravity and projectile range, so they sort of exist already. VS Code isn't the best at detecting this, and so it still has the underlines here, the squiggly underlines, but it is defined. As you can see, this worked just fine. But there's potential that you don't want someone to have access. You define this module, and you don't want somebody to use gravity, or you don't want them to have to avoid this name gravity in their code. Maybe you only want projectile range and you don't want gravity, or you have functions that are defined inside this module that are not intended to be used by others that are importing the function. And so Python provides a way for module writers to sort of protect variable names and to protect function definitions. To do that, you can define a dunder variable called __all. And we can assign this to a list of names to import when somebody writes code like this from physics import star. And so, for example, let's suppose I didn't want anyone to import gravity. And so I will leave gravity out of this list. So I've saved that. I didn't mean to run it, so I'm going to just cancel that. I've saved that, and now over in my main IPyMB, I'm going to restart this again. Remember that it sort of leaves behind some import statements if I don't do that. But I'm going to write the from physics import star. And I'm going to try to run this code again, and it's going to tell me that gravity is not defined. And that's because I defined what the star means effectively when I wrote this __all is just projectile range. And so I can't print out gravity. I can only print out projectile range, which works fine. So that's modules. But there's another more powerful way to import code, and that's packages. So packages are more flexible than modules in that packages are entire folders that contain many pieces of Python code. So if I go over to my example folder and create a new folder directory called physics, and I'm going to drop my physics.py underneath here. I've now created a folder with a Python file in here, but in order to make it a package in Python, I need to add an __init __.py. Having this by itself makes it an importable package, but if you want to also have this import specific files or specific modules, you need to explicitly write them in the init.py. And so I'm going to write that this should run from .physics. So when we have that same module in a package of the same name, we need to use this .physics to specifically refer to the module. But from .physics, import star. Now we can write anything we want here, because remember that running an import is effectively the same as writing the code in the file. So I'm going to save that. I'm back over in my main.ipynb. I'm going to restart this kernel so we can start with a fresh slate. And I'm going to write import physics, so kind of back to our original code. But now the difference is that this is importing the physics package, and so what's happening is init.py is running. Okay, so import physics, now init.py runs, and I'm back to having to write physics.projectile range. Okay, so that works fine. I can try to write physics.gravity. And this gives us an error because module physics has no attribute gravity. And that's again because what was imported here was this init.py. This did from .physics import star, but the all was defined as just projectile range. Okay. So you can see again that import physics worked properly the way we wanted to. Let me restart this one more time. Sorry, I need to be in a cell when I click there. Or at the top of it when I click there. Maybe I need to run something to get it to go into that mode. There we go. Now I can restart. All right. And now instead of writing import physics, I'm going to say from physics import star. Again, referring here to the physics package now. And now I can write print projectile range, and this will work. So that ran just fine. And I can try to write print gravity. It says name gravity is not defined, which is exactly what I want. The last thing I want to illustrate is that there's yet another way that Python allows module writers to prevent things from being imported, and that's by prefixing variable names with underscore. And so instead of writing gravity like that, we can put underscore gravity here and use it exactly with the underscore. And this also prevents gravity from being imported. And so I no longer need this underscore underscore all here because I prevented that variable name from being imported by prefixing it with the underscore. And we can leave our other files the exact same way. But over in the ipynb, let me restart this. Again, so we're starting fresh. And from physics import star, we can still print projectile range. That's going to work just fine. And we could try to print gravity. Gravity wasn't defined, but let's try to print underscore gravity. And we'll see that underscore gravity is not defined. And so we can't access it, even though we don't have that underscore underscore all underscore underscore defined. So if you want to specifically hide a specific variable name, then you can prefix it with an underscore, and that same thing applies for function names. And so this is for if you write a module that you are intending to distribute and you want to use variable names inside the module, but you don't specifically want other people to reuse those names in their own code. So a lot of times if you read a module, you'll see a lot of underscore variable names defined and underscore functions defined. Those are effectively internal function names or internal variable names, not to be used outside the module. In summary, we can create our own modules and packages. Modules are Python files, while packages are a group of Python files in a folder that offers better control over what's imported. One could say that modules are designed for code reuse, while packages are designed for code redistribution.